A few notes from this week, building up to the perfect competition model and then actually looking at the perfect competition model. First of all, we want to remember why it is that the marginal revenue line or price line for a perfect competitor is going to be perfectly elastic and horizontal. The key is that the perfect competitor is a price taker. That means that the price is set by market forces beyond their control. The price set in the market means, let's say a farmer pulls up to the grain elevator and they say we are paying $80 for a bushel. So $80 is the price being paid. It is also going to be equal to the marginal revenue, because if the farmer sells one more bushel, their marginal revenue on that one additional bushel is going to be $80. Total revenue, as we can see on this graph, is an upward sloping straight line, because each unit the farmer sells adds to the farmer's total revenue. And if a bushel is at a price of $80, then the marginal revenue and total revenue for one bushel is $80. But if the farmer sells 2 bushels, that will double the farmer's total revenue to $160, and so on. Total revenue will continue to increase because marginal revenue is going to be a constant. Okay? In a perfect competition, the farmer or the producer can sell as much or as little as they want to at the price. Now that we have the tools we need, we can look at the perfect competitor's level of output in 3 different cases. In this case, marginal revenue, as you can see, is actually greater than average total cost. We always look for where MR crosses MC, and that tells us the output level. So MR crosses MC here, we're going to call that Q1. And when MR is greater than ATC, MR greater than ATC, we can see that the difference between MR or price and ATC is going to be the profit on 1 unit. And if we multiply that by all units, we can see the perfect competitor's total profit. So in this scenario, the producer is going to produce Q1 units of output, realize a profit, and naturally stay in business. In our next scenario, we can see MR is equal to ATC. Again, to find out how much the producer will be willing to manufacture, look for where MR crosses MC, compare that to ATC. Okay, I can see that there is no per unit profit here because MR equals ATC, and therefore there's no profit box, but there's also no loss. Should the firm continue to operate? Yes, because ATC includes normal profit. So the entrepreneur is able to pay all the bills and pay him or herself. So certainly they should stay in business. Third scenario, marginal revenue is less than average total cost but greater than average variable cost. Again, to find the output level, look for where MR crosses MC. Okay, and this time we're going to compare marginal revenue to ATC at this level, and we'll see that ATC is higher. So the difference between ATC and price is going to be our per unit loss. Multiply that by quantity, and we have the total area of loss. Should this producer stay in business? The question is it short run or long run? In the long run, it is unlikely this producer would stay in business. But in the short run, the producer has to continue to pay fixed costs. The producer cannot get out of a contract to pay rent, for example, or a licensing fee, which is being spread over more units. So they are better off actually to stay in business because, as we can see, they are paying all of their average variable costs. Okay? They're able to cover that, and they're paying a portion of their fixed costs, which is better than just paying all of the fixed costs. Option 4 here is where MR equals ABC, and this is what we're going to call the classic shutdown point. Okay, this is still our profit maximizing level of output. Any additional units would cost more to produce than they would bring in revenue. Any fewer would leave money on the table. So this is our absolute best case scenario, but it's a pretty large loss. Okay, and because they are only just covering their average variable costs, they are indifferent whether they stay in business or not. In our last scenario, where MR is less than AVC, it's pretty obvious right away that this is not going to be a good situation and that this producer should go out of business. Okay, the loss is huge. They can't do any better by producing more or less. They're not even covering their average variable costs. So this producer should go out of business. That is the shutdown point. A firm will not produce when it minimizes losses by shutting down. Therefore, the marginal cost curve above and equal to ABC is going to become the firm's supply curve. All right, let's look at the graphs for perfect competition that you're going to need to be able to use. We're going to draw these graphs side by side. The graph on the left has a few key components: price on the y-axis, quantity on the x-axis, traditional supply and demand, and we're going to identify equilibrium price here, and we could also add in equilibrium quantity. Okay, so same supply and demand graph we used in week 2 in our first unit. This time, as we said, the market here is setting this equilibrium price, and that price will be transmitted over to the individual firm as a perfectly elastic marginal revenue curve. The producer can sell as much or as little as they are willing to produce at that price. I'm going to erase my additional line because it's kind of messy. Okay, this is the long run equilibrium position because this particular farmer and all farmers in this situation are earning normal profits, but nobody is earning economic profit. Okay, why is this the long run equilibrium? Well, let's consider what happens if the price happens to be larger. Okay, in order for the price to be larger, there would have to, of course, be a change in this graph on the left. So either supply would have to be less or demand would have to be greater. So let's imagine that demand has actually increased for corn. Okay, the price has gone up. What happens? Each individual producer is going to say, wow, I should be producing more, and each individual producer will be realizing a profit. Okay, and in the short run, that'll be great. They'll have lots of money. Okay, but those profits are going to cause, in the long run, when capital adjustments can be made, are going to cause more farmers to enter this market because remember, there's no barriers to entry. So anybody can join this market. Once those new firms enter, let's imagine tons and tons of farmers enter this market, what is going to happen to the price? Price is going to drop dramatically to this new intersection. Okay, that new price over here is going to dictate that each individual farmer cut back on output, and now each individual farmer is taking a loss, and in fact, even in the short run, okay, a lot of farmers are going to go out of business, but in the long run adjustment, certainly farmers are going to leave, and then what will happen? Supply curve will shift back to the left. So our long run equilibrium situation is going to be where the intersection, okay, of supply and demand is going to be equal to the minimum average total cost of production for each individual farmer. Okay, we've already been through these scenarios when there's economic profit or economic loss. Okay, you will need to be able to assess the impact of shifts in supply and demand in the market, okay, and how they're going to impact the individual farmer. You'll need to be able to see what happens if the individual farmer faces taxes or subsidies, okay, and how those will alter their cost curves, therefore their profits, and ultimately long run and short run adjustments. A few other major points. Okay, in long run, no one is earning or realizing an economic profit. None of the farmers are realizing an economic profit. You might say, well, why would every farmer have exactly the same cost curves? Because if one of them is having more expensive costs, they're going to go out of business. And if some of them are more efficient, their efficiency is going to be replicated in the industry until everybody is just as efficient. So every farmer ultimately should have the same cost curves. No one's earning economic profit. Everyone is earning a normal profit. The firm is productively efficient. Each firm is productively efficient because they are producing at the low point on their average total cost curve. Low average total costs are the definition of productive efficiency, minimum average total costs. And allocative efficiency is also being realized because the price at which the good is sold is equal to the marginal cost of the last unit produced. How do we know that's allocatively efficient? Because if we produced one more unit, it would cost more to produce it than the value society places on it. So we know that wouldn't be allocatively efficient. And if we produce one less, we would know that society values it more than it costs to produce. So that's not allocatively efficient either. Allocative efficiency is when the last unit produced, the cost of producing it, is equal to the price that you can sell it for.